In this video, we will be exploring the switch statements in C++. Switch statements are a powerful tool for multiple branch decision-making in your code. Here's a breakdown of the key components of a switch statement. First, you have an expression, which is usually an integer or an enumeration. Then you have case labels, which are paired with constant values. It's a good practice to include an optional default case to handle situations where none of the cases match the expression. Ensure that you add break statements to exit the switch after a case is executed. Without a break statement, the code will fall through to the next case, which might not always be the intention. Let's see how it looks in code. The syntax starts with the keyword switch, followed by the expression in parentheses. Inside the switch block, you have multiple case labels, each followed by a constant value. If the expression matches a constant value, the code within that case will be executed. The break statement is used to exit the switch statement after a match is found. And then you have an optional default case, which is executed if none of the cases match the expression. Now let's look at a simple example of a switch statement in action. Here, a simple switch statement evaluates a grade and displays a message based on the grade value. We begin with the int main function, then declare a character variable called grade, and initialize it with the value b. The switch statement then evaluates the grade. In the first case, if the grade is A, it will output excellent. Break statement is used to exit the switch case. In the second case, if the grade is B, it will output good job. Break statement is used to exit the switch case. In the third case, if the grade is C, it will output satisfactory. Break statement is used to exit the switch case. If none of the cases match the grade, the default case will be executed, which outputs needs improvement. In this case, since the grade is B, the output will be good job. It's important to understand the fall-through behavior of switch statements. Without a break statement, execution will fall through to the next case. This can be intentional or a common bug. Be sure to use comments to indicate intentional fall-through. Modern compilers may warn about missing breaks. Consider this example. If the day is 1, it prints Monday and then breaks. If the day is 2, it prints Tuesday and then breaks. If the day is 6, there is no break. So it falls through to case 7, prints weekend and then breaks. If none of the cases match, it prints weekday. Enumerations or enums work perfectly with switch statements for type-safe, readable code. Consider this example. First, we have an enum called direction with values north, east, south, and west. Then we have a function called navigate that takes a direction as input. The switch statement then evaluates the direction. If the direction is north, it will output moving north and then breaks. If the direction is east, it will output moving east and then breaks. If the direction is south, it will output moving south and then breaks. If the direction is west, it will output moving west and then breaks. For example, calling navigate with the east argument will output moving east. Now let's compare switch statements with if-else statements. Use switch statements when you are testing a single variable against multiple values, when you have many possible branches or 3+ conditions, when you are working with enums or integral types, when readability is important, and when you want potentially better performance for many cases. Here's an example. On the left, we have an if-else statement that checks the value of choice. If choice is 1, it calls option 1. Else if choice is 2, it calls option 2. Else if choice is 3, it calls option 3. Else it calls default option. On the right, we have a switch statement that does the same thing. The switch statement is more readable and easier to understand. Now let's discuss the limitations of switch statements. It is important to understand what switch statements can and cannot do. Valid switch expressions include integer types, character types, and enumeration types. Invalid switch expressions include floating point types, string objects, and Boolean expressions. Also, case labels must be compile-time constants, not variables or expressions that are evaluated at runtime. Here are some best practices to follow when using switch statements. Always include a default case to handle unexpected values. Don't forget break statements to avoid fall-through behavior. Comment intentional fall-through to make it clear that it is not a mistake. Keep case blocks short to improve readability. Consider using enums for better type safety. In summary, switch statements provide a clean, readable way to handle multiple decision branches based on a single expression. They're especially useful with enums and when testing a variable against multiple discrete values. Remember their limitations and use if-else when switch isn't appropriate. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.